Hi guys, today we're going to do some RapidMiner tutorial. And so basically RapidMiner, it's a platform used for performing data preparation, machine learning, text mining, and predictive analytics tasks. So it is widely known for its visual workflow designer, allowing users to build models without coding, and its wide range of algorithms and extensions. So RapidMiner is also a tool that helps organizations analyze their data, gain insights, and make predictions. So what we're going to do right now is to use a COVID-19 dataset. This is from Kaggle. I'm going to put in the link also for this dataset so you can download it and actually try these datasets. So what's the objective of this tutorial? So the objective of this tutorial is to develop a machine learning capable of assessing a COVID-19 patient's risk level based on their symptoms, health, health status, as well as medical history. The data set used in this report is provided by the Mexican government, which also includes extensive patient information across 21 unique features which were collected from over 1 million patients. The dataset provides important information such as pre-existing condition, disease classification, as well as treatment received. So in this video, we'll look into the dataset to understand its nature and identify the necessary pre-processing steps. So in this part 1, we're going to do data pre-processing. That means we're going to get rid of the missing values and refine the data provided in order for the machine to or the algorithm to actually read it and accurately. So this is the content of the dataset. So the dataset, again, this one, and then for the missing values we have 97. I think 98 is also a missing value here, and 99. So it's basically 97, 98, and 99 are missing data. So, and the rest of the what do we call it, data set is here. The diabetes column. Anyway, this is the data set, and let's proceed to the RapidMiner. So if you start the RapidMiner, you'll get into this page, and then let's start a blank process. After that, we need to upload our data set as well. So we cannot just drag it in the local repository. We need to actually go in the file and then import data. My computer, and find our actual data. So my file is here. So this is the downloaded data, COVID data, and then try to do the next. As you can see, these are the characteristics in here and their values. Let's go next, and just go next and finish. And just wait for it to upload all our data. So here is the result of our data. As you can see, these are the characteristics: the pneumonia, it's in tube, date died, the sex of the data, and more. So let's proceed to the design. So what we're going to do first is basically data preprocessing refers to how we convert and use the raw data into something suitable for the analysis for the machine learning process. This process involves cleaning out missing data and also organizing it to make sure that the data are consistent and intact. Then next is this is our data, COVID data, and we're just going to drag it so here, and then we just clicked on the little circle and then put it in the output section. And then if we try to run process locally, and it will show the data again. So here is the data. So this is the raw data. So the next part of our process is to convert the let's proceed to the result. Before we proceed, we're going to show you some of the tabs in here. So this is the raw data. Here are some statistics. So here we have the missing and visualization. If we need some annotations in here, and then let's proceed to the design again. So first thing we need to do is to convert the data died. This one, data died column, to indicate whether the patient has died, and convert it to 1 if it died and 0 if it is alive, which will be used to as a label later and to identify whether they are high risk patients. So based here in our based in here in our Kaggle dataset, here date died. So if the patient died, it indicates the date of death, and 9999 if not. So as you can see in our data here, some has correct date in here, so that means the patient died. And for these ones, these are patient that is alive. What we're going to do is we're going to convert the date died into 1 as Boolean for dead, and this one 0 if it is alive. Go back here and then go into the operator, generate attributes. If we go here in the generate attributes, we click on the edit list, and then we make another column. Let's name it status and then the function. So if date died, that is the column date died in the COVID dataset, is equal to 99999. So what it means, if that date died is in this format, it means 0 or alive, otherwise 1 which has the date on it, which means the patient died. Let's try this one and do apply, and then let's run again. And as you can see, we have a new column, status, and let's drag it in close to the where's the status, date died. So as you can see, the status is 1 if the patient died, and 0 if it's just generic date. So that's the first step. So we need to know if the patient died or is alive. So if we just use this raw data, the machine won't be able to read it because these are all over the place. There's different date on it, and this one we don't know if it's alive or not. So we need to make it like in a way that the machine can actually read our data. So the next step we need to do is also fix our pregnant status. As you can see in the pregnant status, let's drag the pregnant here, we got a lot of missing values based on our Kaggle dataset. 97, 98, and 99 are missing data. So we have 96, 97 in here, so there are a lot of 97 here, so that means it's missing. We don't know what the actual data with this one, so we need to fix this one as well. And 2 is not pregnant as well, so it means, and there are a few, I think there are a few ones in here which means the patient is pregnant. So we need to fix that as well in order for the machine to actually read it. So let's go back to the design and add this one again, and then add entry. We're going to name it pregnant fix, and then the expression. So if sex is equal to 1, if pregnant is equal to 1, then 1 and 2, otherwise 2. So next is to, now we fix the pregnant section. I'm going to explain what the function means. So the expression means, as given already in the sex column, 1 is for female and 2 is for male. So if true, if sex is equal to 1, it's 2. We need to proceed here first. If pregnant is equal to 1, so it's going to be 1 because that's actually pregnant. If it's not 1, then it's going to go default to 2. So next one is if sex is equal to 1 already, then it retains the 1, otherwise 2. And then let's apply this one. If there's some expressions that comes error, it will show our red marks in here. Like for example, if we put in like period and not a comma, see, it will show an error as a red mark. So we need to be careful with this one and then replace it with comma, and then run again, and then you can see that there's a new pregnant column here, pregnant fix. So in here it fixed the missing value, it converts it to 2, so we don't know. So that means we in average we're going to use that it's not pregnant. And if we look into here, there's a lot of data in here, so I don't know which. I think there's one here. There's here, as you can see, there's 1. So it's pregnant. The patient is pregnant, so the pregnant fix is 1. So here we converted this pregnant column into pregnant fix, which the machine can now know if the patient is pregnant or not. If it's pregnant, it means 1. If it's not pregnant, it means we converted it to 2. Same thing with the missing values, we just converted it to 2. It means they're not pregnant, which is our average, or average for that one. Next step is to, in our pre-processing, is to identify the missing values such as 97, 98, and 99 and replace it with average value of the attributes to prevent data loss. So let's go back to the result in here. So as you can see, there are 0 missing values in here because there is no actual missing values in our data. The missing values in our data has been renamed to 97 and 99. So if this is blank or blank like this one, it will show in our result in here as missing. But in our case, it's what the owner of the dataset here did was converted to 97, 98, and 99. So we need to figure out on how to convert it in order for the machine to actually read those numbers. Next is we put in the replace. We go in our operators again, and then we need to declare missing values. Put in here. We can't put in like multiple numbers in here, so we just do it. We have to do it one by one. I had to do it. I don't know if you can add multiple numbers in here, but that's what I did. Do the first numeric number, so 97. So that means all attribute that has numeric value which is 99, we're going to declare it as a missing values. And after that, we're going to do the declare the 98 again, this time for the 98 missing values, and then we do another one for the 99. We're just going to drag it and then put it straight in the line so it connects automatically, and then put in the 99, and that's it. And then we run it again. See, it converts all these, the 97 and the 99s, into question marks. Question mark means it's missing values now. So as you can see, there are multiples here with in here too. And we can also look at the statistics. In the statistics area, we can see there are a lot of missing values now. In the intube, there's like 855,000 missing values. Pneumonia, 16,000. In the pregnant area, we got 527,000 missing values. And the rest, here's the rest of the data in the ICU as well. So next step we're going to do is to replace the missing values. Just go in the operator again and type in the replace missing values, and then use the default. The default for this one is average, so we're going to use the average as the value for the missing values, and then run it again. And then there's no more missing values here. Missing values is gone. It converts to the average of that column. So if it's mostly 1, or so it converts the missing values into 1. If it's not, then 2. And lastly, for our pre-processing step, is we use we're going to select attributes. So in here, we're going to do all attribute, exclude attribute, and then a subset. So include attribute and then a subset, so we can choose all of this. We're going to add all the attributes except for the ICU, and then the intube, and then the pregnant, because these three have the more a lot of missing values, which has like 855,000 missing values, which we don't want our we don't want the machine to read, because they don't have any relevance to our data already because of their missing values, and they might just be like noise in our data set. So we're going to add the rest and leave the ICU, intube, and the pregnant column because of their missing values, and then apply, and then run again. Now we have it all, and then let's proceed the data status again, and then here. So as you can see, we have the date died here, status here, and the rest of the columns that we selected. There's no more missing values in here in the statistics section. So that's it for our pre-processing of our dataset. And then let's look at into the next video for the part 2, in order for us to do the next step, which will involve the model implementation of our data, splitting the data, and using different models, supervised learning or unsupervised learning, like the naive-Bayes, decision tree, and all those models. And that's it for our data processing tutorial for RapidMiner.